Hi everyone, this is Pooty. Today we are going to talk about thread programming in Java. Before introducing the thread concept, we were unable to run more than one task parallelly. It was a drawback. Hence, to overcome this drawback, thread concept was introduced. In this video, we will be learning about what is thread, lifecycle of thread, advantages and disadvantages of thread concept, and then thread priorities demonstration. We use thread concept in Java to perform complicated tasks in the background. The program runs more efficiently when threads are implemented as it allows multiple tasks to be executed at the same time. All the tasks are executed without affecting the main program. In a program, all the tasks have their own separate paths of execution, so each thread is independent. A thread is a very lightweight process, or we can say the smallest part of the process that allows a program to operate more efficiently by running multiple tasks simultaneously. Another benefit of using thread is that if a thread gets an exception or an error at the same time of its execution, it doesn't affect the execution of the other threads. Life cycle of thread in Java is basically straight transition of a thread that starts from its birth and ends on its death. So let us understand how to identify thread states in Java thread lifecycle. A thread is a path of execution in the program that goes through the following states. The five states are as follows: new, runnable, running, blocked, and dead. The first state in the thread lifecycle is the new state. In this state, when the thread is created, it is a new state. New implies that thread object has been created but it has not yet started. At this point, thread is considered to be not alive. It is the state before the start method is invoked. The next state is runnable state. In this state, a thread is ready to run and is moved to runnable state. A thread might actually be running or it might be ready to run at any instance of time. It is the responsibility of the thread scheduler to give the thread time to run. The next state is running state. In this state, a thread is in running state when it requires to start execution. Then it is known as active thread. Based on the situation, the next possible state is block state. In this state, the thread may be entered into block state by using suspend, sleep, or wait method. A thread is in block state when its execution is temporarily suspended. The final state is dead state. In this state, a thread is in dead state when its execution is completely or forcefully stopped. Then this is done by using stop method. Now let us consider a real-time example of a music player. The moment you tap on the button to play the audio, a thread is created and you see the thread starts proceeding and your song starts to play. From the runnable state, it enters the running state and it keeps on running till the song is not finished. Hence, that is like terminated state. In in case in between, you just go for the pause. That's where the thread is going to do the wait operation. So when your song is automatically finished or you just stop the song, that is the terminated state. So this is how the thread works. Let us go through few advantages of thread. Enhanced performance by decreased development time, simplified and streamlined program coding, improvised UI responsiveness, simultaneous and parallelized occurrence of tasks, better use of cache storage by utilization of resources, decreased cost of maintenance and better use of CPU resources. These are the few disadvantages of thread: complex debugging and testing process, overhead switching of context, increased potential for deadlock occurrence, increased difficulty level in writing a program, and unpredictable results. Now, let us go through an example program to demonstrate thread priorities. In this program, we have created three classes named as class A, class B, and class C, with each class extending the thread class. All the three classes perform the same task, which is to print a string in a for loop. In our main method, we have created three objects named T1, T2, and T3 from class A, class B, and class C respectively. For each thread, we have set different priorities. As you can see, For T3, we have set the maximum priority, which is 10, and for T2, it has been set as 5. And for T1, it has been set the minimum priority. When the start method is called based on priorities assigned, the T3 has the maximum priority, hence it will be executed first, and T1 has been assigned the minimum priority, hence it is executed last. Thank you.